Our final practice problem for section 12.4 on the cross product is question number 9, and it's a general proof of this statement: u cross v dotted with v is equal to 0 for any u in v. And of course this should be true because remember, u cross v will produce a vector that is perpendicular to both u and v. So whatever it is, it will be perpendicular to v, and we're dotting it with a v. And we already know that the dot product of perpendicular vectors is 0. So this should turn out to be true. We know it intuitively. Let's prove it in reality. Okay, in order to do this, we need to assume coordinates for u and v. So u will be at u1, u2, and u3. And v will be at v1, v2, and v3. Next, we have to calculate the cross product between u and v. And of course, the easiest way to do that is to set up the matrix. So I, negative j, and k, u1, u2, and u3, v1, v2, and v3. And what this is going to give us is a vector with the following coordinates. We block off the I row and column, and that's u2, v3, minus u3, v2. And that will be in the I direction, or the I component, the x component of the cross product. Minus, block off the j row and column, u1, v3, minus u3, v1. And that's in the j hat direction, or along the y direction. Finally, plus, block off the k row and column, u1, v2, minus u2, v1. And that's in the k hat direction. Okay, so the vector that represents the cross product of u cross v is going to be u2, v3, minus u3, v2, comma, negative u1, v3, minus u2, v1. Oh, u3, v1. And then the third component's going to be u1, v2, minus u2, v1. And that's the vector that represents the cross product. Now we need to dot that with v. So I want to take this and dot it with v, and of course v is just v1, v2, v3. So let's multiply these out. To take the x component, it's just going to be v1 times this, so it'll be u2, v1, v3, minus u3, v1, v2, plus the middle component's going to be v2 times this, so I'll just reverse the signs on them, so this will be the positive term. It'll be u3, v1, v2, minus u1, v2, v3. And then finally the last one, plus, it'll be u1, v3, v2, minus u2, v1, v3. Now if we look at this really carefully, we've got u2, v1, v3, that's the first term, and the last term I just wrote is the negative of that. So those become 0. I've got negative u3, v1, v2, and here's positive u3, v1, v2. Those also become 0. And finally, u1, v2, v3 plus u1, v2, v3. There's plus and minus of the same term, so they also become 0. So this proves it. The dot product of any vector with a cross product that contained that vector will always be 0. And we've proved it for any vectors u and v.